Bună ziua. Hello to everybody. I'm very happy to be here today. I'm very happy to be in this beautiful country. And I want to talk about a topic today that is about something strange and legacy systems. Legacy systems, you know, are these systems that have a screen with a black background and green and yellow letters, and you hardly need to use the mouse, and you can click on the tab key to go from one input field to the other, or use the F keys to go from one screen to the other. So that's legacy systems and yeah, requirements management. I have to admit I tricked you a little bit into it. Requirements management is just a part of something else I want to talk about. That's requirements engineering, but that sounds just too technical. So I was afraid everybody's leaving when it says requirements engineering. But requirements management is a part of it. But if you want to manage requirements, and I'm talking about requirements of an IT system, then you first have to determine them, to gather them, but you also have to document them and to validate them. And all of it together is requirements engineering. And as Serge said already, there will be a workshop in the afternoon, and I would be happy if some of you join me there. Then we can go into more detail. So how is requirements engineering embedded in the whole software engineering lifecycle? Oh my God, engineering again. We can also call it IT project instead of software engineering lifecycle. Maybe you feel better with that. Before an IT project starts, there will be some business process consideration analysis, or there might be a strategic project where many of you will be involved. And the result of such a project can be we need to develop a new software or to change an existing software. And then we have our IT project where requirements engineering is very essential to have the success of that project. And it's also the first step in that project before the next steps start, like technical design, technical architecture. Then the developers come into place and test. And after go live, we have an application management and support the people. And then you see another engineering term there, that's reverse engineering. What's reverse engineering? That's also a kind of requirements engineering, but it's a post-documentation of systems. You have many systems that are not well documented, but sometimes you need them to be documented. Reverse engineering I will explain later again. First, let's go back to the legacy systems. Yeah, legacy systems, many users like them because they're very fast, they are used to them, they are reliable, they don't break down so often. But when it comes to introducing new products to the market and fast, then we run into problems. It was mentioned earlier, the new products in the car industry. Legacy systems are quite unflexible. It's difficult to enter new products quickly. The costs of that is very high. So what they really are, they are a barrier to innovation. So at some point or another, you need to do something about these legacy systems. And I want to introduce three options, three alternatives, what you can do about them. So one is modernization. So I keep the old system and have to modernize it. The other one is replacement by an off-the-shelf product. Oh, sorry, I see there's an F missing. And the third one is new development. So you can also develop a system and develop it to your needs. All three of them they are put into practice by an IT project. And if you have an IT project, as I said before, you need requirements engineering. But before you start an IT project, one precondition has to be fulfilled, and that's what I mentioned earlier. You have to have a documentation of your old system, so reverse engineering comes into place. But the good thing is you don't need a bunch of developers to go through each line of source code in your old system. There are some tools on the market that help you, that support you doing that. And here I have one example. I just worked in such a project with this tool. The source code is just entered into a so-called hypercube, and then the system analyzes everything. It compiles the source code again, and so you get some quality checks on it as well. But the analysis about the content of the tool is supported by lots of graphics in that tool. So you can save up to 90% of the efforts compared to developers going through each line of source code for that post documentation of the old system. But now we talk about the three options I mentioned. The first one, modernization and further use. Of course, you need that documentation. You also might need the documentation of the changes you want to put into the system. And the whole IT project is, compared to the other two options, not so costly. It's a low cost, or at least short time. But on the right-hand side, the modernization options are limited, and if you have ever-changing fast requirements, then this option is not really advisable. Of course, you could take the source code of the old system and put it into some tools that translate it for you. So from an old language like COBOL or PL1 into a modern language like C# or Java. But then you have modern language and old structure in the code, so you need a re-engineering project to put some modern structures into the code as well. So if that doesn't all fit your needs, then you have to choose one of the other two options. And the first of those was the replacement by an off-the-shelf product. Here it is very much essential to have proper documentation of the requirements you want, so that you can take the system documentation of the product you want to introduce and compare it to what you want, and to look at the deltas. If you're lucky, you have a stable system that you introduce, but the disadvantages are, first of all, the product you want to introduce has certain processes that might not fit your processes. So you have to have lots of customization in the product if you want to stick to your process, to your internal insurance processes. And this will be very costly again. And also in the future, when you have new versions of that product, the costs are there again, because you have to adapt your customization to the new version again. So, but there is a way out. You can choose a product that is built, that is a modular system. So you can imagine like Lego building bricks, that you can build the modules so they fit your need very much. Then it's easier to adapt to those process needs. We at NTT Data, we have systems that are on this modular basis. For reinsurance, it's called First Re. For primary insurance, First Gen, and we also have one for life insurance called First Life. But we also have a system for passive reinsurance that's called RISE, like Reinsurance Administration and Information System. So that could be a compromise. If that all doesn't help, then you only have the option to build a new system that fits your needs. And here it's most essentially, of course, again, to have a proper requirements documentation. So you can build a system that fits your needs and doesn't have bugs. Of course, this option has probably the highest costs. And the bigger the system is you want to build, the more risk you have of a project failure. But there are three things that you have to follow in order to reduce that risk. Always do an agile development project. Secondly, split this big system into small modules to have smaller projects. And of course, you need to train your IT team, especially in requirements engineering, but of course also in the agile methodology like Scrum. Yeah, let me summarize everything. If you want to stay competitive in the market and want to enter new products in the insurance business, then you need a system that is modern. You need to modernize or replace your legacy system. I have introduced three alternatives with their advantages and disadvantages, and mentioned different forms of requirements engineering. And again, the invitation, please come to my workshop in the afternoon to have an inside view into requirements engineering. Thank you very much.